Happy New Year, ladies and gents. Welcome to the first video of 2021 for second year geographers. So to try and cheer us all up, I've gone for a very nice, funky, bright background. I thought we might all need a bit of that. And I just want to say one thing before we get started. You will probably hear me coughing during this video. I've had a test, it's negative. I think it's just a bog standard cold. I assume that's what it is. So don't be too alarmed if you hear me coughing, okay? Right. Before Christmas, we were looking at kind of the foundations of the weather and climate model, all about pressure, all about insulation, albedo, solstices, lots of new words that I threw at you. The last thing that we did before Christmas was we introduced the UK climate, the cool western temperate maritime climate, and we introduced the meaning of weather and climate, and we also talked about what those things are like in the UK. And one of the things that we established is that the weather in the UK changes a lot. What the weather's doing when you get up in the morning could be completely different to what the weather is like by lunchtime, could be completely different to what it's doing at tea time. Our weather changes a lot, and what we're going to do today is we're going to find out why that is. So for this year's module booklet, you need to be on page 28, which will say UK weather at the top. And yeah, here we go, ladies and gents. So the first thing that I need to get across to you is the fact that there are various reasons that we have for why the UK's weather is so changeable, some of which we kind of know about already, some of which we've introduced but we haven't done fully. So the first reason is the jet stream, which we have talked about, but we'll do a little bit of revision of that today. The second reason we've introduced, when we were talking about influences on the weather or climate of a place, and we said, so for example, your latitude, how far north or south of the equator you are, will have a massive impact on the weather and climate of the place you live in. But then we said it's not just latitude, it's altitude, it's ocean currents, it's whether you're coastal or inland. And we did talk a little bit about wind direction. And what I said to you at that point is the wind will bring the characteristics of where it's come from. That's what we've said today, but so far. But today we'll be updating that information with a little bit more detail. Then we've got these things which will be new to you, depressions. We've talked about high and low pressure. And depressions are the type of low pressure that we experience in the UK. And these are a significant part of our weather. Now, you probably at the moment call them storms, and that's generally what they're called by most people. Meteorologically, they're called depressions, all right? So storms, depressions, low pressure, they are a big part of our weather. And then we have the opposite of that. We have something called an anticyclone, which is an area of high pressure and brings completely different weather. Some revision, some new stuff, but that's what this video is going to work its way through. Right, jet stream. Please don't worry learning the diagram on here. It's merely there to prove a point to you. We're not particularly interested necessarily in 2003 and 2004. It's the idea that the jet stream moves. It moves north and south of the UK. It can be over the UK. And what we've done in class already is we've drawn a series of maps of the UK with the jet stream moving north, south and over the top. And we've just said each one of those scenarios, excuse me, will give you completely different weather. For those of you who are interested, you see the red arrows are for the jet stream in 2003. So the jet stream was north of the UK, which means we were the warm side of it, and 2003 with a heat wave. whereas 2004 was not quite such good weather, and that's because the jet stream was over the UK and it was bringing all of the storms. I tend to think of the jet stream as a conveyor belt of bad weather. So jet stream moves. Now obviously you can access this PowerPoint and have a look at this yourself. This is a map of where the jet stream is right now. And what you can see is that the main part of the jet is actually to the south of the UK. There is this break-off bit, but it's not going right over us. What does that explain? Well, first of all, it explains why it's cold at the moment, because the jet stream is mainly to the south of us, which means we're very firmly in the polar cell. And it would also explain why, if I look out of my window right now, it's not raining, it's not windy, because you know, the jet stream is not over us right now. Okay, so moral of the story number 1, jet stream moves. Now these 2 videos I'm not going to open on here. It's a bit like a Russian doll, isn't it? It's a YouTube within a YouTube. Anyway, these 2 videos I would have a watch at your leisure, please. I will give you access to this PowerPoint, so you can access these. But these are all about our second part of the jigsaw, which are air masses. There's a Met Office version and there's a BBC version, and they're both really, really good. And this links to the map that you have on page 28 of your module booklet. And you will see a map of the UK with 5 arrows going towards it. And at the moment, all you've got around those arrows is the name of each air mass. What I would like you to do, please, is to add the detail that you can see from the slide right in front of your very eyes. And I would also like you to watch the videos and add any notes that you can from there as well. The moral of the story is, just think about a map of the world and think about where that arrow is coming from. If you will accept that the wind will bring the characteristics of where it's come from, if the wind is coming from the Atlantic Ocean, but it's coming from the south of the UK, it's coming from the tropics, which is going to make it quite warm, but it's coming from the sea, which is going to make it quite wet. So it's quite logical. This is the best air mass in terms of nice weather. This is coming from North Africa. If we think of 2 adjectives that would describe North Africa fairly effectively, you'd go with hot and dry, wouldn't you? And that's the kind of weather that the air mass brings. They're quite logical. This one is what the media generally refers to as the beast from the east, because look, ladies and gents, it's coming from the east. Who knew? And it's referred to as a beast because it generally brings us some quite cold, snowy weather. Now, the beast from the east is actually something the Met Office are keeping an eye on this week at this very moment. Some of you may have experienced snow over the last couple of days. I live in central Taunton and I haven't seen any snow, but certainly I know some people have. And they are predicting that later this week we may see more snow, and it's all linked with that air mass there. So just one thought that might have popped into your head about that. So this is coming from Central Europe. You might be thinking, well, hang on a minute, if it's coming from land, why can it bring snow? And if that question has popped into your head, I am very impressed, ladies and gents. That's really excellent. There's just enough water vapour collected over the North Sea here for it to create precipitation. Here, look, particularly if it crosses here, it doesn't get a chance to pick up very much, but here it just provides enough to create some snow. So, moral of the story number 1, the UK's weather changes a lot because the jet stream moves. Second part of the story, the wind can blow from 5 main directions, and which direction the wind is blowing from at any particular time will change the kind of weather that we are experiencing. These 2 are our dominant ones, and very shortly we're going to be talking about frontal rain and depressions, and if we've got frontal rain and depressions, it's generally these two working together. So you've got the warm air coming from the tropics, you've got the cold air coming from the poles. They meet, they cannot mix, and we've said it's a little bit like a convergent plate margin where the oceanic crust is always the one that's subducted because it's denser and heavier. Well, the cold air from the pole is dense and heavy, so it's forced down. This is forced to rise, and then you get your low pressure. So they are our normal ones, okay? Right. So, more funky backgrounds, just because I thought you might all need, I don't know, just something fun to look at, really. Depressions, low pressure systems, right. I tried at the very beginning of the module to emphasise just how important understanding pressure really is. And yeah, this is all low pressure. So all of that is really revision, but we'll do it step by step. In your module booklets, I am first of all going to say to you there is probably more information about depressions than you actually need. And that's something that has dawned on me over the last sort of year or so. And I'll just explain why. In the old specification, you had to know depressions inside out, upside down, back to front. You could have had very specific questions about them. Now, the only way that you can be tested on this module is by writing an essay. And so we need the big picture, the big ideas of weather and climate rather than too much of the nitty-gritty detail. So can I just first say, there are pages and pages on depressions. Don't get too bogged down in it. That's my mistake, basically. And what we need is to, just get the big picture of them. They begin on page 31, and what I'm going to tell you is what you need to know. Right. Little bit of revision first. There are 3 types of rainfall. You need to know that for year 1, water and carbon, and year 2, weather and climate. We get relief rainfall, or orographic, if you want to give it its posh title. Air is forced to rise over hills and mountains. As it rises, it cools. That gives you condensation, clouds, rain. We also talked here about the rain shadow effect. This one is convectional rain. We don't get this very often in the UK because to get convectional rain, you need it, to be hot. So as the sun shines, hot air rises. As it rises, it cools, it condenses. Right, you get the same end result. This is the one that we're now interested in. This is frontal rain, which I've briefly recapped already. Cold air meets warm air is less dense, warm air is forced to rise. So please can I just remind you before we go any further, what is the same in all 3 of these types of rain is that air is forced to rise. What is different for each of them is why the air rises. But anyway, in a depression, this is what happens. You have the warm air from the tropics meeting the cold air from the poles, and that gives you what we call a front. The other use of the word in a sort of similar context, unfortunately, is in war. So you have where you have the 2 sides meeting each other, you can call it like the Western Front or whatever. So it's generally used kind of as a meeting point. Anyway, this is the type of rainfall associated with depressions. The other thing we already know, low pressure means that the air is rising. If the air rises, you're going to get clouds and rain. Talked about that already. The other thing that you get, if the air is rising, what you could end up with is a vacuum here, no air. And that's going to be fairly disastrous for life as we know it. The other thing you get with low pressure is wind. And all these arrows are representing is air rushing in to replace the air that's rising. What that means, ladies and gents, then, is that depressions or storms are associated with cloud and rain and wind. This is our bad weather, okay? Now we get, and it tells you this on page 31, we get these lasting for anywhere between 1 and 5 days. We get about 100 of them a year on average. And every single stage of a depression or a storm brings slightly different weather. So if I can just take you back to the very beginning of this video, we are trying to find out why the UK has such changeable weather. We've got jet streams moving, we've got air that can blow from any 5 directions, and each one brings different weather. We've now got these depressions, we get about 100 of them a year. They last between 1 and 5 days, and each stage of them brings different weather. So you can begin to see that there's a huge amount of reasons as to why our weather changes so much. Now, on a Met Office pressure chart, we've talked about the winter of 2014 before, but this is what a depression looks like. You're looking for L's, low pressure. You're looking for numbers below 1,000. The lower the number gets, the worse the weather will be. All right. So a low of 942 is pretty low, to be honest. A low of 972 wouldn't be that bad. The lower the numbers get, the worse everything gets. Okay, and that's because think about it. The faster the air is rising, the faster it has to be replaced. Therefore, the lower the pressure, the faster the air is rising, the faster the wind's going to blow, the faster all of this happens. Low numbers are bad. You don't need to know this, but just for your kind of interest, the lowest pressure ever recorded is 888. That was recorded in America. I believe that the lowest pressure measured in the UK, but it doesn't mean it can't get lower than this, is 953. As you can see, it's possible for it to get much lower in other places. Anyway, the lower the number, the worse the weather, okay? And what you would have had to have known in the old spec is what all of these red and blue things mean. But to be honest, you don't need that level of detail now. All these symbols are telling you is it's where warm air and cold air are meeting, which I've said to you is called a front, but you don't need that level of detail for this spec. Now, I've got a diagram, I've got a text version, and I've got a PowerPoint animation to show you for this. The most important thing for you is to have a rough understanding of how the weather changes as a depression passes over the UK. All right, so this is the text version. This is the diagram, and can I just point out to you that you start here. So you start at 0 and work this way. It's a bit counterintuitive. This is the first weather conditions you would experience. These are the last weather conditions. And you have that diagram on page 33. But let me show you this as well. Depression walkthrough. Okay, so I will also give you access to this. It's a little bit temperamental at times, but bear with it. I think it's definitely worth it. So it starts off with this diagram, and then you get this little animation. Okay, so this, maybe it's going to be, sorry ladies and gents, are we not going to work? Okay, what I'll do is I'll send that to you, and what happens is this little stick person here experiences all of the weather that you would expect to get in a depression, and I shall persevere and see if I can get it to work for you. Yeah, sorry about that. The first sign you get are some clouds in the sky, which look like this. These are cirrus clouds, ladies and gents. Do you need to remember the name of all the clouds? No, you don't, not at all. But if you want to show off and impress the examiner, then good for you. These little thin wispy clouds are the first sign that a depression is on its way to you. As the beginning of the depression gets closer, the cloud will get lower in the sky and it will begin to rain. So these are the cirrus clouds that are the first sign. As this gets closer to you, you're going to start to see the cloud get lower and lower in the sky, and it's going to start to drizzle a few kind of clouds every now and again. It will be beginning to get a bit windier. Okay, so the weather here is not great, but it's not the end of the world. And the clouds, these are the sort of typical clouds you get with this stage, where you can't really see any blueness. It's all a bit grey and depressing, but it's probably not raining that heavily. It's showers or it's drizzle. Then in the middle bit, this is quite weird. The weather's actually quite nice. It's quite good right in the middle bit. You may have heard of the calm before the storm, which is sort of what this bit is. Then the very worst weather is associated with this stage. It's called the cold front, and it's where you get these. These are called cumulonimbus, and if you translate from the Latin, that means big pile of rain. So cumulonimbus are the big thunderclouds, heavy showers, really intense rain. That's definitely the worst bit of the depression. And then afterwards, you get the kind of clouds that you would draw. If you said to a child, well, or me actually, draw a cloud, we kind of draw these, don't we? They're sort of the beginning of The Simpsons, they're sheep without legs, they're the fluffy cotton wool balls, whatever you describe them as. These are your sign that your depression is over. So you've got definite differences in the cloud as the depression passes. And remember, this could take 24 hours to pass, but this could take 5 days. So you would lengthen each one of these stages, and it might take sort of a day or two for this stage, and then a day or two for this stage, and then a day or two for this stage. These are a massive part of why the weather in the UK changes so much. Now, next time we have a lesson, we are going to talk about case studies of them. And we talk about two. We talk about 1987 storm, which is also known as the Great Storm. Not because it was great, but because it was terrible. And the main features of that one are the wind. 15 million trees are blown over. A ferry gets washed onto a beach. People die. It changed the face of weather forecasting forever. And then much more recently, we're going to look at the the storms of 2014, which are famous for the flooding of the Somerset Levels, the coastal erosion around the southwest, storm surges, etc. So we will be picking up on them next time. Now, that was low pressure, air rising, clouds, rain, wind. Finally, we're going to finish by talking about anticyclones, which are the opposite. High pressure, air sinking, no clouds, no precipitation, no wind. The very opposite of one another. These are our good weather, sort of. Okay, so anticyclones. And anticyclones begin on page 39. But actually, what you'll notice when you look at page 39 is it's mainly questions for you to answer. So you can answer them partly from what I'm going to tell you in the video, but you also have a geo fact sheet starting on page 40, which has got lots of answers in it as well. Right, you're looking for H's, okay? You're looking for high pressure, and I used yesterday because we're in high pressure, so it seemed sensible to use what was going on at the moment. We're looking for numbers above 1,000, and the higher the number, the more stable everything is. it means that the anticyclone is likely to be hanging around for some time. So you can see here we've got 1,030, 1,029. This is a very stable anticyclone at the moment. Notice higher numbers, H's instead of L's, and far fewer of these red and blue and purple lines, which are all about warm and cold air meeting. And that's where you get your frontal rain, etc. Okay, why am I showing you a picture of nothing? Well, that is kind of the point. You are looking at empty skies or clear skies, skies without clouds in them. And that's very much a feature of an anticyclone. If you can see the stars at night, it's an anticyclone, okay? There are no clouds in the way. And that's a very, very important thing to remember. But what we have to focus on is the difference between a summer anticyclone. There's a picture of my retirement plan right there. I'm just going to sit down, take in the view and have a nice old time. And winter anticyclones, which are a very different kettle of fish. So let me endeavour to remind you. We have talked at some length about the fact that the sun changes position relative to the earth. I know the sun doesn't move, but relative to the earth. We've talked about solstices and equinoxes and where the sun is overhead. And I've only put these images up on the screen to remind you of that information. The ITCZ, which is the hot, wet bit where the two Hadley cells meet, moves with the seasons. So in June, we have the longest day in the Northern Hemisphere. That's our summer solstice. It's our longest day and it's the beginning of summer. And the sun is in the Northern Hemisphere, keeping us nice and warm. Thank you very much. We have just recently had the winter solstice, which was on December the 21st, and that was our shortest day. And we're in winter because the sun is now heating the Southern Hemisphere. Australia and New Zealand are hotter, we are much colder. So we're back to all that kind of stuff. So if I can just take you back to this, if you've got clear skies and the sun is in the Northern Hemisphere, it's going to be hot, it's going to be lovely. If the sun is heating up the Southern Hemisphere and you've got clear skies, it's going to be sunny, but it's going to be cold because the heat is being directed to the Southern Hemisphere, not the Northern Hemisphere. And I've attempted, I'm so sorry, I've attempted some diagrams really badly. Okay, clouds, we don't have them in anticyclones. This is just to prove a point. If you have cloud, it's a bit of a pain in the backside during the day because it actually blocks sunlight from getting to you. So you get less sunlight reaching the Earth's surface because the cloud gets in the way. Whereas if you had an anticyclone, you get maximum sunlight. However, at night time, clouds are quite helpful. And we've talked about this in the past, and I've likened clouds to being a bit like the duvet on your bed. The point of the duvet on your bed is to trap heat around your body and keep you nice and toasty warm. Well, that's what clouds do, because at night time, when the heat re-radiates, the clouds trap that heat and they keep it, so it doesn't get that cold at night time in low pressure. If you don't have any cloud at all of that heat can just be lost. And this is the reason that in a desert, it can get to over 50 degrees during the day, but it can drop below freezing at night time because there are no clouds blocking the sunlight coming in or stopping the heat from leaving. Okay, so I've put a text version above. Summer anticyclones are hot and lead to heat waves, droughts, etc. There's no cloud blocking the insolation coming in, so it's nice and hot. The heat is lost at night, but because it's our summer, we have long days and high temperatures, it never gets that cold. Winter anticyclones, it's sunny, the sunlight can get in, but because the heat is quite a long way away from the UK, it's sunny, but it's cold. And overnight, all of this heat gets lost. And that means any water vapour in the air will either cool to liquid, which gives you fog, or it will cool to a solid, which gives you ice. All fog is, ladies and gents, is droplets of water hanging in the air. It is essentially cloud at ground level. And this is exactly how fog is created. Okay, so let's show you that picture. Here, look. What's happened here is all of the heat has been lost overnight, and so the water vapour that's in this air has cooled down and it's turned into liquid droplets. They're teeny tiny droplets, so they hang around in the air, and then you get this fog. Gradually, as the day warms up, that fog will disappear. And it hasn't disappeared, it's just that the water liquid has turned back into a vapour again. It's all about the fact that water can be a solid, a liquid or a gas completely based on temperature. So fog is water vapour turned into liquid droplets because it got cold overnight. If it drops below freezing, and I'm sure a lot of you have seen icy mornings recently, then that's exactly what's happening, all right? The temperature dropped below freezing, and therefore, instead of turning into droplets, it turned into a solid, and that's where you get your ice from. Sorry. So page 39, which you may already have started filling in, has got a series of questions about anticyclones which will enable you to get everything that you need to know about them. You can get those answers from what I've just been telling you in the video, or, as I said earlier, you've got a geofact sheet that starts on page 40 that gives you lots of answers already. Now, what I will do is I will try and see if I can get Stickman working and share him with you. Yeah, I'll persevere with that. And then go back to your email to see what you need to do now you've reached the end of the video. Thanks, folks. Bye.